Jai Hind students, welcome to physics class of grade 11. Last time we were discussing about the applications of dimensional analysis and we have discussed the two applications. One is to check the dimensional accuracy of a physical relation and the second application that was discussed by us was the to derive a physical relation on the basis of the dimensional analysis. Now the third application, it is also a very important application, that is conversion of one system of unit into other. Conversion of one system of units into other. Now this application is very important in NEET IIT entrance examination. Questions based on this application, it always comes. Now let me explain let this application. All of you know that conversion of one unit into the other unit. For example, if I want to convert Newton into its CGS unit, what I will have to do? If I want to convert SI unit of acceleration into CGS unit of acceleration, how this can be done on the basis of dimensional analysis? Let's do that. First of all, it is based on the fact that magnitude of a physical quantity always remains the same irrespective of the system of unit. Magnitude of a physical quantity always remains the same, always remains same, whatever be the system of unit. Let me explain what is the meaning of this statement. For example, let us say there is a length of 5 meter. Let us say this is the length of the 5 meter. If I say that this length is 500 centimeter, will this change? It will not change. If I say that this length is 5000 millimeter, will it change? It will never change. It will remain the same. Even if you purchase, let us say 10 gram of the gold, if you say that I have purchased 10,000 milligram of gold, will the amount of gold will increase? It will not increase. It will remain the same. If you say that distance between your school and your home is 5 kilometer, if you say that this distance is 5000 meter, will it increase? It will not increase. So what does it mean? Magnitude of a physical quantity, it does not depend on the system of unit. So what can I write in this case? L equals to 5 meter, it can be written as 500 centimeter and it can be written as 5000 millimeter. So if I say Q is a physical quantity, then what is 5 here? 5 is its numerical value. And what is M? M is the unit. So I can write it is equal to N1, U1, N2, U2, N3, U3 and so on. N stands for the numerical value and U stands for the unit. Here in this case N1 is 5 and U1 is 1 meter. What is N2? 500. And what is U2? U2 is 1 centimeter. And what is N3? 5000. And what is U3? This is 1 millimeter. So this means that, so it is based on the fact that q it equals to n1 u1 n2 u2 n3 u3. If I increase n1, then the size of unit will decrease. If you say 5 meter, and if I increase this n1, let us say I make it 500, then unit will become smaller, it will become centimeter. Now let's do this. Now let dimensional formula of q is m to the power a, l to the power b, and t to the power c. I'm taking it as the q equals to n1 u1 equals to n2 u2. If m1 is unit of mass in this system, L2 is unit of mass in this system, and T1 is the unit of mass in this system. I'm repeating, M1 is the unit of mass in this system, L1 is unit of mass in this system, T1 is unit of mass in this system. Then what can I say? I can write M1 to the power A, L1 to the power B, and T1 to the power C. N2, let us say M2 is unit of mass in this system, L2 is unit of mass in this system, T2 is the unit of mass in this system. Then what can I write in place of this? I can write in place of this as M to the power A, L to the power B, T to the power C. From here, the value of the n2 can be calculated as m2 to the power a, l to the power b, t to the power c divided by m1 to the power a, l1 to the power b, and t1 to the power c. Right? In this way, I can calculate the value of this. Now to make it more simpler, I can write this as m2 divided by m1 to the power a, l2 divided by l1 power b, and t2 divided by t1 to the power c. Now let me explain this with the help of an example. I say convert 100 Newton into CGS unit, into its CGS unit. How can I convert 100 Newton into its CGS unit? All of us know that Newton is SI unit of the force, and the measure formula of the force is MLT minus 2. So, right? And we know that N1 U1 equals to N2 U2. I will use this concept here. N1 is numerical value, U1 is size of unit, N2 is numerical value, U2 is the size of the unit. Let us say N1 here is 100 and U1 here is 1 Newton. Why I have written? Therefore N1 U1, how much it will become? 100 multiplied by 1 unit, that is it will be the 100 unit. Now what is N2? I have to calculate. And what is U2? 1 dyne. Why? Because dyne is CGS unit of the force that you have studied in the grade 9. So if I say N2 U2, how much it will become? It will become N2, I have to calculate, multiplied by the 1 dyne, that is N2 dyne. Now I will use this to calculate the value of the N2. Let me calculate this. Now N1 U1 equals to N2 U2. So N1 here is 100 and U1 here is 1 Newton. N2 is, I have to calculate, and U2 is 1 dyne, and dimension formula of force is MLT minus 2. Now what is 1 Newton? 1 Newton is SI unit, and in SI unit I know that mass is measured in kilogram. So in place of M I will put 1 kilogram, and in place of L I will put 1 meter, and in place of time I will use 1 second to the power minus 2, right? And N2, it's CGS system, and in CGS system SI unit of mass is 1 gram, and length is 1 centimeter, and time is 1 second. So what I will do, I will cut those. Second is cancelled from here because they are the same. Now to solve this, convert kilogram into gram, 1000 gram, and meter into centimeter. We know that 1 meter is 100 centimeter. It will be N2 multiplied by 1 gram into 1 centimeter. All of you can say gram and centimeter, they are also being cancelled. So what I got N2 equals to 100, 1000, 100. So I got this. So much of this, so I can say 100 Newton is equal to 100 followed by the 5 zeros dyne. So on the basis of dimensional analysis, I converted 100 Newton into the dyne. Let's do one more question. If I say, listen students, SI unit of work is joule and CGS unit of work is arg. That you will also do in the +1, and you might have done in the grade 9 also. SI unit of work is joule and CGS unit of work is arg. Now what we have to do, we have to make we have to convert 20 joule into arc, right? And dimension formula of work is, all of you know, ml square t minus 2. What you have to do, very simple, just like this, joule SI, you will write the SI unit of M LT here. So this is 20 multiplied by multiplied by M is 1 kilogram and L is 1 meter. Here you will write 1 meter square, and time is 1 second to the power minus 2 and dash. Let us say this value is N2. And what is arc? CGS, M is 1 gram, and here 1, L is 1 centimeter, and what is time? 1 second to the power minus 2. What I will do? Now cancel the like terms. So again convert this 20 into 1000 gram, And how many meters are in 1 centimeter? There are 10 to the power 2 centimeter in 1 meter. So I'm writing this. It is N2 multiplied by 1 gram multiplied by, if I solve, open this bracket, 1 square is 1 and centimeter square is centimeter square. Now cancel the like term. Here gram is the like term. So what can I write? I can write it here as 2 into 10 to the power 4, 23, 4 zeros. And if I open this, 10 to the power 4 centimeter square, it is equal to N2 into may 1 centimeter square. So from here I can cancel out this centimeter square. So how much I will get? I will get this as N2, it equals to 2 into 10 to the power 8. So I can say 20 joule equals to the 2 into 10 to the power 8 arg. Okay, let me give you one more question. This question is again similar to this. It's very simple. Listen everyone, I say convert, very simple, convert 20 gram per centimeter cube into kilogram meter per cube. So how can I calculate this? Let's do this. Now use N1 U1 equals to N2 U2. What is N1? 20 gram per centimeter cube. What is N2? I have to calculate. And what is U2? It is kilogram per meter cube. So here it can be written as 20 gram per centimeter cube. And what is N2 here? So, and how many kilograms are in 1 gram? 1000. So let me write it as 1000. And how many centimeters are in 1 gram? 100 centimeter. So write it here as 100 centimeter to the power minus 3. So when you solve this, gram is cancelled by the gram. So what I got, and also 1 0 is also cancelled. So what I got, 2 centimeter minus 3 to power minus 3 and 2 into may 100 multiplied by, and what is this? When I open this, 100 to the power minus 3 centimeter to the power minus 3. So what will happen? This centimeter minus 3 get cancelled. So how much will it come here? This will come as 2 equals to N2 into may, here bases are same, so powers get added. So this will be 1 minus 3. So how much this is? N2 multiplied by 100 to the power minus 2, 2. So how much I will get? N2, when this 100, it will go there, it will be 100 to the divided by 2 divided by 100 to the power minus 2. So when it will come in numerator, I will get 2 into may 100 to the power 2 and 2. So what I got N2 is 2 multiplied by 100 to the power 3. Now, so what can I say? I can say that what can I say? I can say that 20 gram per centimeter cube is equal to 2 into 10 to the 100 to the power 2. So convert this. So I will get 20,000 kilogram per meter cube. So in this way I can do this conversion, right? Next is, let's do one more question. We know that capital G, what is this? Universal gravitational constant. You studied its value in grade 9. Its value is 6.67 into 10 to the power minus 8. If I say its value is 10 to the power minus 8, in CGS system is dyne centimeter square per gram square. Find its value in SI system. How can I calculate its value in SI system? It's very simple. We have done capital F equals to capital G m1 m2 by my r square. My target is to calculate dimension formula of capital G. So this is fr square divided by m1 m2. And what is force? mlt minus 2. I told you, remember few formulas, L square. And what is this m1 mn? So it's cancelled. So what I will find? I will find m to the power minus 1 L cube t to the power minus 2. So this is the dimension formula of the capital G. Now my target is to convert this. It is very simple. Let's do this. I know N1 U1 equals to N2 U2. And what is N1 given? 6.67 into 10 to the power minus 8. And what is U1? 1 dyne centimeter square per gram square. This equals to N2. What is U2? U2 is SI system. In SI system, what is the unit of force? Unit of force is Newton. Unit of length is meter. And unit of mass is kilogram. I have to do this conversions. So how can I do this? Let's do, it's very simple. 6.67 10 to the power minus 8 into 1 dyne. If I say, right? Now, dyne centimeter square per gram square. What I will do, in place of this, I will write this in CGS system. So what is the unit of mass in CGS system? It is gram. 1 gram to the power minus 1. And what is unit of length? It is 1 centimeter square. And what is unit of time? It is 1 second to the power minus 2. And this is N2. And what is in SI system? Unit of mass is kilogram. What power I have to raise to kilogram? Minus 1. What is unit of length in SI system? Meter. 1 meter cube. And what is unit of time? 1 second to the power minus 2. Here power will be 3. Now, what I have to do? I have to cancel out the common terms so that my calculation becomes easy. So, let us do this. 6.67 multiplied by 10 to the power minus 8 into 1 to the power minus 1. And what is the gram to the power minus 3? And what is this? Centimeter cube. It equals to N2. And how many grams are in 1 kilogram? 1000 gram. So my target is to cancel this. And how many centimeters are in 1 meter? 100 centimeter cube. Let us solve this. 6.67 10 to the power minus 8 multiplied by gram minus 1 centimeter cube and 2 multiplied by 1000 to the power minus 1 gram to the power minus 1 100 cube centimeter cube. So when I will take it out, it get cancelled. So this N2, how much it will be? 6.67 10 to the power minus 8. What will happen? It will come in denominator 100 to the power minus 1, and how much it will be? 100 to the power 3. Here bases are same, so powers they get added. So what is N2? N2 will be 6.67 10 to the power minus 8 divided by 100 to the power 2. And how much can I write this? This was 1000. So 1000 to the power minus 1. So 1000 to the power minus 1, 100 to the power 3. So N2 it equals to 6.67 10 to the power minus 8 divided by, what is 1000? Here this is the multiplication. So what I will do? I will convert it into the power of 10. 10 to the power 3 multiplied by, and what is this? 100 equal to 10 to the power 2, its cube. When you will solve this, 6.67 10 to the power minus 8 divided by 100,000, this is 10 to the power 3, 10 to the power 6. So when you will solve this, 6.67 10 to the power minus 8 divided by, now again student, it was having negative sign, how much it will come? 10 to the power 3. So now you take it as upwards, 6.67 10 to the power minus 8. When it will go there, it will also become, its power will negative. So it can be written as 6.67 multiplied by 10 to the power minus 11. So I can say, so put here, so what I will find? I can say 6.67 into 10 to the power minus 8 dyne centimeter square per gram square is equal to, how much? This is equal to 6.67 10 to the power minus 11 Newton meter square per kilogram square. So what this is this is SI unit, and how CGS system can be converted into the SA system. Let's do few more numericals. Now there is a question. I say x equals to a plus bt plus ct square, where x is measured in meter and time is measured in second. Find dimensional formula of ABC. How you can find the dimension formula of ABC? Now my question is, x equals to a plus bt plus ct square. What does this indicate? Now a is added to bt and bt is added to ct square. What does it mean? All are having same units. If a is meter, bt is also meter, ct square is also meter. If they are having the same units, then their dimension formula must be same. So, writing the dimension formula on both the sides. So, what is the dimensional formula of x? It is L. What is the dimension formula of A? A is, okay, A formula I have to find. And what is the formula of B? I don't know. What is the formula of this? Time is T. And what is the formula of C? I don't know. I have to calculate what is the formula of T. It is again capital T, T square. So, using principle of homogeneity, the formula of each and every term should be same. So formula of A is L, and formula of BT, it is again L. So if I find it, this BT will be LT minus 1. And what is the formula of C? CT square, it equals to L. So formula of C is LT minus 2. So these are the how we can calculate the dimension formula. Let's do one more question. What's the question is? P equals to A minus T square divided by Bx. What is P here? Pressure. And what is dimension formula of the pressure? Force upon area. Formula of force is MLT minus 2. Area is L square. So how much it will become? M L to the power minus 1 T to the power minus 2. And what about the dimension formula of X? It is position, and dimension formula of T, it is time. My question is, find dimension formula of A, B. Now first of all, A minus T square is given. So what does it mean? A and T square have same dimensional formula. Therefore, A, it equal to T square. Now, P equals to A minus T square upon Bx. Dimension formula of A minus T square, it will be again T square. So writing the dimension formula on both sides, what can I write? P formula is M L minus 1 T minus 2. And what is A minus T square? It is T square. B I have to find. Dimension formula of X is L. Right? Now what I will do? Simple calculation. Shift this here, B take it there. So this B, it will be T square divided by M L minus 1 T minus 2 multiplied by L. L get cancelled. So how much I got? When this M, it goes upward to the numerator, what does it become? T to the power M to the minus 1, and it will become T minus 2, it will be positive. So how much it will be? T square multiplied by T square. So I can say M minus 1 T to the power 4. This is the answer. So that's all for today. Thank you and have a nice day.